Good morning, everyone. This is Anushya, your host for today. Welcome to today's exciting tri-party webinar titled Real-Time AI Sensor Fusion with Econ Systems Holoscan Camera Solutions using Lattice FPGA for NVIDIA Jetson Thor platforms, presented by Econ Systems, Lattice Semiconductor, and NVIDIA. We are happy to have three interesting speakers with us today. Gomati Shankar, Director of US West at Econ Systems, Gambus Galilian, Senior Director, Ecosystem Strategy and Partnerships at Lattice Semiconductor, Neil Patel, Senior Solution Architect at NVIDIA. Each of our speakers brings deep expertise in the respective domains. And audience, the Q&A section is open now. Please feel free to type your questions into the chat at any time during the session. With that, let's dive right in. Over to you, Neil.
Thank you, Anushya. Hi, good morning, everybody. My name is Neil Patel. I'm a Senior Solutions Architect at NVIDIA. And today, what I'm going to be covering is going to be a brief overview of the Holoscan Sensor Bridge, which is really about bridging and making it easier for you to be able to integrate multiple sensors into your applications. So there are really three big challenges that we're trying to solve with the Holoscan Sensor Bridge. The first is that many applications have many sensors, as well as many different types of sensors. Systems may have 5 or 6 or sometimes even more. And there needs to be a way to easily both synchronize these said sensors, synchronize the data between the sensors, and also be able to integrate these different types of sensors and have them easily talk to your compute. Historically, it has been realized by leveraging PCIe or other interfaces, and data management is complex when you do it like that. Mission-critical applications such as endoscopes, for example, or robotic surgeries need really low latency. And you need to be able to communicate with the sensor at extremely high speeds and need to be able to process data in real time. The other challenge is also security and AI safety, where the increased data from all these different sensors necessitates AI safety guardrails and cybersecurity, because you want your data from the sensor to be secure when it's coming to compute. So we created Holoscan Sensor Bridge. And these are the key benefits of Holoscan Sensor Bridge. The first is that it's low latency. With Holoscan, you will be able to quickly process real-time sensor data and capture real-time sensor data and process it on the GPU. The other key thing that is often needed with these mission-critical applications is being able to stream into GPU memory directly. And with IGX platform that supports ConnectX, this allows you to do RDMA. It is also a scalable architecture. So for those 5 or 6 or even more, however many sensors you have, you can easily scale from one to many sensors, enabling almost up to 100 gigabytes per second of data. It is multimodal, so instead of having to worry about each individual sensor and then doing the development of the driver for each sensor for your compute, because all the sensors are aggregated and come in via Ethernet, it makes it extremely streamlined, so you don't have to worry about driver development. The other thing is synchronization. Synchronization can often be important, and you need to be able to communicate between multiple different sensors in a synchronized manner, so you get data very coherently. The next is Sensor Bridge is secure and reliable. So it supports features like redundancy, some security protocols, failure detection, so that you can make sure that the data is secure between your sensor and your compute platform. So this is really what the architecture looks like, very high level. There are 3 components to this architecture. There are your sensors on the left here that you see. There is the Holoscan Sensor Bridge. And then on the extreme right, it's going to be the compute platform. And so the architecture basically is that you have your different types of sensors. They could be cameras, could be LiDARs, could be radars, or RF sensors, could be anything. And they come in via the I/O plane. And we have a custom HoloLink FPGA IP that handles both the control plane as well as the data plane. And then it packetizes all the sensor data into UDP packets and sends it to the compute via 10 gig Ethernet. You also have the ability to bring in your own sensor. So depending on what your application is, you can either work with our sensor partners to get one of their sensors, or bring in your own sensors, and Holoscan will work with both. And so jumping a little bit more into detail about what the Holoscan Sensor Bridge FPGA IP is, I mentioned that there is a data plane and then there is a control plane. The data plane is mainly for data transfer of relevant sensor data. And what happens is it gets packetized into UDP packets. And then the control plane takes care of the data transfer that's relevant for your host. So you can easily communicate between the host and the sensor. The control plane could be receiving and decoding UDP packets from the host to access the registers that are going to be transmitting specific network protocols across the sensor bridge. The IP is fully configurable, so you're able to configure the number of sensor interfaces, the number of host interfaces, width of interfaces, as well as frequency of interfaces. There is also an APB bus for read and write operations. Jumping into a little bit of details for the Holoscan Sensor Bridge software now. The thing that's great about the Sensor Bridge is that from the sensor's perspective, you don't need to write kernel space drivers to support all these various different sensors. It's going to be completely user space. This full stack solution really ensures that the data provided at the FPGA sensor interface can easily stream over to our compute. So with our NVIDIA IGX platform, you can leverage streaming DMA via the Connect and the ConnectX, and on the Jetson, we support CPU emulation that still leverages the low latency aspects of the sensor bridge. So the key thing about the sensor bridge from a software perspective is streaming DMA, the ability to easily access control interfaces like GPIO, I2C, SPI, things like that, the transport abstraction layer, and also the ability to access the Linux sockets. We're working with a number of sensor vendors to integrate the sensor bridge directly into the sensor. So depending on what type of sensor you need or you're looking for to integrate into your application, you will also be able to leverage that. These are some examples of where the Holoscan Sensor Bridge can play a huge role. Applications that are mission critical, such as medical robotics and medical surgeries, humanoid robotics, autonomous robots and machines, which rely on a lot of sensors and need to process a lot of sensor data, Holoscan is going to be a valid candidate for these type of applications. Other applications like visual agent, you go back a slide. Other applications such as visual agents and edge HPC and inference can also benefit from the use of Holoscan because of the high-speed sensor processing. Pivoting from our discussion a little bit, I also want to touch on the compute side of things, which will actually help you make use of the data that you're getting from the sensor bridge. That is where the NVIDIA Jetson comes in. And the latest in the family of NVIDIA Jetson is the NVIDIA Jetson Thor, which is the ultimate platform for physical AI and robotics type workloads. It provides up to 2070 FP4 teraflops of performance and is powered by the Blackwell GPU architecture. We've also increased the memory bandwidth as compared to the previous generation. It supports up to 273 gigabytes per second of memory bandwidth. This is tremendously useful when it comes to processing multiple sensors, such as we see in the applications today. The Jetson Thor module and the Jetson Thor developer kit are available now to purchase, so you can start your development on them. These are the two different Jetson Thor modules in the lineup. We have the Jetson T5000 and the Jetson T4000. This slide lists the comparison between the two SKUs. As you can see, the T4000 provides up to 1200 FP4 of performance and has a 12-core CPU compared to the